We are now ready for problem 48. There are 3 problems left in this Math 137 online midterm review. 48, they first give us a trig function. It says if the sine of theta equals 7/10, and they tell us the angle theta is in quadrant 2. And then they say to find the exact value, they give us 4 parts. So the first one, they want us to find the exact value of cosine of theta. Now you could find cosine of theta using identities, but of course, by now, if you've watched me work out problems, you know I like to go ahead and just take a trig function, sort of create a right triangle. Sine is 7/10, so kato is so, opposite over hypotenuse. Then to find this bottom leg, you take the hypotenuse squared minus the other leg squared, 100 minus 49, square root of 51. And of course, I need to remember this angle theta is in quadrant 2. So to find the cosine, so ca adjacent over hypotenuse, and it's negative. Cosine is negative in quadrant 2. So that's pretty straightforward. I think B, C, and D is where they're really getting at the problem they want you to solve. The first one is the sine theta plus pi over 6. So an interesting problem, because what it is we're actually adding 2 angles and then taking the sine. Now it's interesting, the angles, one of the angles is just an angle, pi over 6. We can go find, if we go to our unit circle, pi over 6 is right here. And the other angle, if we want to learn about that, we can use this right triangle we've created. So let's go ahead and go to our sort of formulas for the sine of the sum of 2 angles. Let me just write it out. So it's the sine of the first angle times the cosine of the second angle plus the cosine of the first angle times the sine of the second angle. So now we can go ahead and plug in. You should have numbers for all of these. Sine of theta, 7/10. Cosine of pi over 6. What's the cosine of pi over 6? Square root of 3/2. Cosine of theta, we just calculated that, negative square root of 51/10 times the sine of pi over 6 is 1/2. If I multiply the 2 fractions of 7 square root of 3/20, actually, just to save some time, I know when I multiply these 2 fractions, my denominator is 20, so I can add these 2, or actually subtract because I got a negative here. But anyways, hopefully it's pretty clear to you. Then you multiply out the 2 fractions, then you add the 2 fractions. You end up with this right here. And that is the correct answer. So part C, now they're asking for the cosine of theta minus pi over 3. Same idea as in part B, except now we need to go and find the formula for the cosine of the difference of 2 angles. And that's simply going to be the cosine of the first angle times the cosine of the second angle plus the sine of the first angle times the sine of the second angle. So now just plug in all the numbers. Cosine of theta is negative square root of 51 over 10. Cosine of pi over 3. Pi over 3 is right up here, right? Cosine is just 1/2. Plus the sine of theta is 7/10. Plus times the sine of pi over 3, square root of 3 over 2. So once again, going to have a denominator of 20. Actually, since I have a minus here, I'm going to sort of change the order. 7 square root of 3 minus the square root of 51. And that's correct. And then the last one, which could be a little messy. Why did I say that? Because now they're asking for the tangent of the sum of two angles. The formula for the tangent is a fraction. So it's going to be tangent of the first angle plus tangent of the second angle over 1 minus the tangent of the first angle times the tangent of pi over 4. So we need to go figure out tangent of theta. Easiest way is if we go back to our triangle, tangent TOA, opposite over adjacent. So 7 over square root of 51. And because it's in quadrant 2, it's a negative. So it's negative 7 over square root of 51 plus tangent of pi over 4 is just 1 over 1 minus tangent of theta, negative 7 over square root of 51 times tangent of pi over 4, which is 1. Now let me go and combine these, combine this fraction, this one. So to get a common denominator, the 1 is going to end up being square root of 51 over square root of 51. So let me write this as square root of 51 minus 7 over the square root of 51. Down here, I'm going to have 1 plus 7 over square root of 51. If I want to combine that into one fraction, I've got to make that square root of 51 over square root of 51. Like I said, I thought this was going to get messy. So here I'm going to have square root of 51 plus 7 over square root of 51. So I have two complex fractions. If you simplify this, these cancel out. And I'm left with square root of 51 minus 7 over square root of 51 plus 7. Of course, they don't like us to leave this radical in the denominator. So I'm going to multiply by the conjugate, top and bottom. So for the bottom, I could do my little shortcut. You take the first term and you square it, minus the second term squared. Now the top, I can also sort of do a little bit of this in my head. So square root of 51 times square root of 51 is 51. Negative 7 times negative 7 is plus 49. And then you end up with negative 14 square root of 51. So when you FOIL this, that's what you should get. So you get 100 minus 14 square root of 51 over 2. And now the 2, you can cancel out a 2 in both of these, and you get 50 minus 7 square root of 51. Fractions always make it messier, but there you go. All right, number 49. So here now we're back to looking at some problems with inverse trig functions. The sine of the sine of inverse, the sine of the inverse sine of 0 plus the inverse cosine of 1/2. Now inside here I have inverse trig functions, but because I actually know, remember, anytime you have an inverse trig function, this result is an angle. I actually know what the inverse sine of 0 is, right? Inverse sine of 0 is, what's the angle where the sine is 0, and I can only look on this side. Well, obviously it's 0. Here, what's the inverse cosine? What's the angle where the cosine gives me 1/2? I can only do it for the top. Turns out it's right here, pi over 3. So this really becomes a problem of 0 plus pi over 3. So it really becomes a pretty simple problem. And what's the sine of pi over 3? Square root of 3 over 2. Now the next and the last problem is similar, but a little more tricky. Let me write it, then I can describe to you in what way it's similar and what way it's different. The sine of the inverse sine, so it's starting out the same way, but here the inverse sine is 5 over 13. Here it was 0, plus the inverse cosine of negative 8 over 17. So it pretty much is the same format as the previous problem, except instead of 0, you got 5/13. Excuse me, instead of 1/2, you have negative 8 over 17. Now, the interesting thing is, when I looked at this problem, I knew these angles. These ended up being special angles. So I was able to right away plug in 0 and pi over 3. I do not know what these angles are. Matter of fact, for this problem, I'm actually going to call this angle 1 or theta 1 and call this theta 2. I don't know what those are. But for now, let's just go ahead, instead of writing inverse sine, inverse cosine, let's just call these theta 1 plus theta 2. What I want to show you is that now I'm going to go and apply the formula for the sine of the sum of two angles, which is sine of the first angle times the cosine of the second angle plus the cosine of the first angle times the sine of the second angle. Now I just need to figure out what are the trig functions for these two angles here. Now, this may be a little confusing, but what I'm going to do is let's think about what do we have when we're looking for the inverse sine of 5/13, and we're calling that theta 1. In our heads, we say, let's try and find an angle in the allowed region, an angle where the sine is 5/13. I know that this angle now is going to be over here somewhere in the first quadrant. I'm going to rewrite this just for this problem. You can't do this all the time, so be careful. This doesn't work all the time, but for this problem, I can re-express this as the sine of theta 1 equals 5/13. Because when I do that, I then can take this theta 1 and create a right triangle, 5/13. 13 squared minus 25. It's 160. I believe this whole thing is 12. So this is a right triangle for theta 1. I know it's in quadrant 1. I can do the same thing for cosine of -8/17. I'm calling that theta 2. Now I know this is really the same thing for this problem. I can say this is really the same thing as saying cosine of theta 2 equals 8/17. I know that theta 2 is going to be in quadrant 2. I'm going to go ahead and create a right triangle for theta 2. And it's going to be 8 and 17. So 17 squared minus 64. And when you do that, work this out, ends up being 15. So by doing this, I now can actually plug in numbers for all these here. So let me try and do this. So sine of theta 1, this is my triangle for theta 1. Of course, I already know the sine. Sine of theta 1 is 5/13. And cosine of theta 2 is -8/17 plus cosine of theta 1. It's going to be so ca 12/13, and it's in quadrant 1, so it's a positive number, times the sine of theta 2, 15/17. And in quadrant 2, the sine is a positive number. So now, once again, minus 40/13 times 17 is 221. 12 times 15 is 180. End up with 140/221. All right, so this one is a little tricky because these two expressions here are both angles. And you sort of take that information and sort of work backwards and create right triangles. And it's easiest just to call this theta 1, theta 2, and we apply our formula here. And then with our right triangles, we can plug in all the information and get the answer. So, interesting problem. All right, that wraps up the problems for this midterm exam review.